Please welcome to the stage Vice President, Java Developer Relations at Oracle, Chad Arimura.
Hello. The world really has been moved by Java, hasn't it? Well, we've got a packed agenda, so let's jump right in. This is the Inside Java Keynote, named after the website inside.java. That's a URL. It's a website where we aggregate content directly from the team that builds Java. You know that you're getting content that's directly from the source, accurate, and captures the intent and the vision behind why features were built. Think of it like an inside look at how the platform is developed. Like the website, today's keynote is an inside look at some of the innovation that's going on into the Java platform. But before we get there, we have a very special guest that's going to talk about how Microsoft is helping push the Java ecosystem forward and how they're using Java heavily inside of Microsoft. I'm honored to invite Julia Liuson to the stage, President of Microsoft's Developer Division and GitHub. Julia?
Well, thank you, Chad. Hello, everyone. It's a great honor to be here. Before I get started, I just want to say a huge thank you to Oracle team for giving us this opportunity to be here and to collaborate over this talk. We really appreciate the partnership we have formed with the Oracle team. In keeping with today's Inside Java theme, I want to share with you the journey that Microsoft has been on with Java and our work to advance the Java ecosystem at Microsoft. Now, some of you here are probably wondering, like, Microsoft, Java, is this for real? Isn't Microsoft known for .NET and C++? Well, you might be surprised to learn that we actually use Java extensively with a tune of over 2 million JVMs in production. The truth is that until we actually created a dedicated team to work on Microsoft's OpenJDK, we didn't actually know how many Java usage we had inside Microsoft. Now, we don't just use Java. We actually use Java to run some of the most important and significant workload at Microsoft. LinkedIn, which Microsoft acquired back in 2016, uses Java at a very massive scale. Their Kafka clusters process over 5 trillion messages and 5 petabyte of data every day. And recently, working with Microsoft's OpenJDK team, LinkedIn has migrated over 300,000 JVM instances from Java 8 to Java 11 and observed a 26% improvement in performance. Now, Jesse J from LinkedIn is here at JavaOne, and we'll be doing a booth talk tomorrow and really talk about their Java 11 migration experiences. So please swing by if you are interested to learn more. Another very important workload at Microsoft is Minecraft. We have seen peaks of up to 100,000 VMs per day through the Azure PlayFab services. And beyond LinkedIn and Microsoft and Minecraft, Azure's core infrastructure, Microsoft's Bing search engine also use Java pretty extensively. And you can see some of the stats on the slide. And you can see the volume is quite massive. Now, not only that we use Java extensively inside Microsoft, we're also empowering thousands of some of our biggest customers to run their business applications using Java. One of the customers we want to talk about today that's running Java apps at a massive scale is FedEx. So a lot of us probably have seen a tracking dashboard like the one you see on screen while we're expecting a delivery. So at the time when the global supply chain has been impacted, ensuring that their customer actually receives their packages within the established ETA is at the heart of FedEx logistics system. And as a customer, we really get to see just our own dashboard. But FedEx have to deal with pretty massive volume. And to deal with this volume, FedEx launched a Java-based solution running on Microsoft Azure. That is their global delivery prediction platform. Now, this platform dynamically predicts ETAs for more than 16 million shipments a day. And it does more than 10 times a day for each package. And this entire calculation is powered by over 800 million events every day. Now you can imagine the skill that really involved to run an operation like this, and then see that the application has a huge impact for customers who are probably expecting some time-sensitive deliveries. Given the volume of the shipments, all parts of this application need to operate at cloud scale with very high reliability and availability. Java Spring App is the compute platform that FedEx has chosen for processing this 800 million messages for their prediction system. FedEx chose Azure Spring Apps because of its ease of use and auto-scaling capabilities, and the fact that it's a fully managed service. The integration that Azure Spring App has with other Azure services also enable FedEx to move very quickly with confidence in building and delivering applications as a part of their worldwide web presence. Now, this is an example of how you can really build a globally available digital application experiences where you can just focus on your application and depend on platform to provide the reliability and the scale. Now, at Developer Division in Microsoft, our mission is to empower every developer and every development team to achieve more. We have invested significantly in improving end-to-end experiences for Java developers. Whether you're using Spring or any other popular Java frameworks or application middleware, Azure supports them natively with tight integration with the rest of the platform and partner services. We'll support any application architecture, from monoliths to containers, all the way to completely event-based microservices architecture. To ensure your investment can work seamlessly on Azure, we have partnered with Oracle, launching jointly developed solutions for Oracle WebLogic Server on Azure, and on Azure Kubernetes services. We also support middleware from IBM, such as WebSphere Application Server, WebSphere Liberty, and Open Liberty on Azure. The Red Hat JBoss EAP on Azure enables you to deploy your Jakarta EE applications with integrated support from both companies. Last but not least, if you use Tomcat with Azure App Service, you can quickly build, deploy, and scale your Tomcat web applications on a fully managed Linux infrastructure. Now, from a tooling perspective, we focus on delivering a significantly improved developer productivity with our investment in the Java extensions for Visual Studio Code, as well as in GitHub Copilot, leveraging AI to give you more productivity. The Microsoft build of OpenJDK is a no-cost distribution of OpenJDK that's open source and available for free for anyone to deploy anywhere. From DevSecOps perspective, we have strong support in GitHub Actions and in Azure DevOps for Java developers to continuously integrate and deploy your application updates. And you can use GitHub Advanced Security to perform secret scanning, code scanning, and dependency scanning to keep your app secure. Now, to show you how to take full advantage of the ease, security, and the scale capabilities, I would like to invite Mike Heckler on stage to do a demo. Mike?
Thank you, Julia. I'm Mark Heckler, Principal Cloud Advocate of Java and JVM languages, and I'm excited to share some cool tools we're working on at Microsoft and GitHub to make Java developers' lives easier and better. For this demo, we'll be working with the Acme Fitness Store, a fictitious online retailer. Great developers deserve great tools like GitHub Codespaces and Copilot. Codespaces clones the target repo and opens it in VS Code in a cloud-based container, making it fast and easy to work from any machine with tools configured the way you choose. You're the captain of your code, and Copilot helps you fly through your code base. Its AI assists and amplifies your expertise, and it is fast. It's a real force multiplier. GitHub Advanced Security watches your back, helping protect against the leakage of sensitive information to public repos. Moving from code to deployment, analytics gives you priceless insights into your production systems to determine optimizations for maximum performance and scalability with minimum cost and downtime. Finally, load testing stress tests your apps to ensure they're ready for the potentially crushing success that awaits them once they hit production. You work hard. It's time for your tools and platform to level up and work just as hard for you. So this is a high-level summary of the architecture used. An API gateway controls access to the Acme distributed application, providing routing, rate limiting, security, and more. Our front end offers an engaging UI with access to various back-end APIs provided by mostly Java services, but with a couple other non-Java services in the mix to represent the polyglot platforms most of us work with. Behind the scenes, various supporting services provide the scaffolding to support our mission-critical storefront application, which I will switch to right now. Perfect. Okay, great. So this is our storefront, and it does all the things that a storefront should, right? It shows me logged in, which is, of course, because I've logged in. We can go and peruse the catalog, choose something we might want to purchase. Perhaps I've been looking at a new smartwatch, so I go in and take a look at that. And of course, from there, I can do all the usual things. I can add it to the wish list, I can add it to the cart, I can purchase it, and hopefully it'll be there by the time we get home from JavaOne. But you didn't come here for the front end, right? I mean, we're here to see the good stuff. So let's dive into the repo. Let's dive into the code. Now this is something, let me expand that just a bit. This is something you're used to seeing, right? We're all used to seeing this on a nearly daily basis. So when we go to a repo, we go to the local tab, we git clone this to our local machine, and assuming we have all of the setup already done with the JDK and our tooling and all that, then we can get started. But Codespaces takes that on up a level. As I mentioned, it spawns a cloud-based container using VS Code. And of course, you can configure that with the plugins and tools of your choice, the configuration settings. I'm going to just skip ahead here, and we'll take a look. Refreshing. Literally refreshing. So I'm going to go inside here, and let's expand our API for our product controller within our Acme catalog. So we see that we have a couple of endpoints already. We have the products endpoint, which returns a listing of all of our products, and then a specific product request. Let's go ahead and add to that. I'm just going to add another endpoint. And instead of doing an inventory, let's grab a product's name by its a specific product's name. So it's just that fast. Copilot has jumped to the conclusion that I want this kind of code. And let's be real, this code is almost as good as mine is. So that looks pretty good, right? Those of you who know my code know that's a joke. So by providing the ID for the particular product as a path variable, we pass that to our product service. We return the name based on the product retrieved and an HTTP status code of 200. Looks good. Copilot doesn't just work for code. It can also work for comments. So returns name of the product. That looks good. And you can go ahead and expand that here if we want to be consistent. Returns a single product, etc. And you can take this just to whatever extent you want or don't want. It's all in your hands. Returns a list of all products. Yeah, it's just that easy. So I'm going to save that, and let's go ahead and push that. So I'm going to commit the changes. It asks me, since I haven't staged them, would I like to stage and commit them? And of course, yes, please. And let's go ahead and sync those changes. Oh, looks like we might have a problem. Let's go in and take a quick look. And we see, let me expand this just a little bit for better visibility. And we see that, yes, indeed, there may be a particular problem because I've inadvertently tried to push a Redis access key. This is a problem. I was doing some things with the Docker Compose file, got a little carried away, and it's telling me that GitHub push protection has caught this and watched my back. If I go directly to this file, then I see that, yes, indeed, this is a problem. This is not something you want to happen. You don't want to wind up on the news. So at this point, what I can do is simply go back and undo my last commit. And then we can go into this granularly if we want. I'm just going to unstage the changes. And then perhaps I want to just undo the changes entirely. So changes, well, we'll discard all changes. We'll go ahead and proceed from there. But now we need to take a look at our console, at our portal. And this is a very focused portal. This kind of gives us the high-level view of what's going on within our distributed application. From there, we can drill in here. This is a place I like to start because this is the application map. And there are different ways you can visualize this, but what I like to do is pick out the one or ones interactions with the longest time, right? And 35 milliseconds is pretty quick, right? Maybe there's no problem at all, but maybe there's something that I could look at optimization or optimizing in that regard. And we can drill into the performance. If I go here, I can investigate performance and go right in and look at it in various different ways. In this case, we have operations, and we can see the various different operations and what may be long-running operations. We can check the dependencies. We can drill into a particular request and see what's happening in component calls. We can look at the roles based on the cloud role, so the different components and instances of those components. And of course, we can go to load testing and make sure that our application is ready to withstand the rigors of production. If you see a load test here that we've just run recently, we can see the various different useful information. Now this is only about 26,000 requests per second, which works out to about 2.25 billion requests a day. So I think we're ready to go. We have a 14 millisecond response time. We have this really nice error percentage rate. That's so nice. And from there, let's go back over and we'll wrap up. A bit more information about the architecture. Azure Spring Apps is a platform purpose-built for Spring and Java applications, but it supports other languages as well. Everything is based on Kubernetes without the pain normally associated with Kubernetes. So in our short time together, we took a quick look at the Acme Fitness application, its architecture, and its deployed components. We saw how GitHub Codespaces and Copilot work for you to make your life easier and more productive. Next, we watched GitHub Advanced Security stop a potential leak of credentials to a public code repo. And finally, we saw analytics and load testing offer optimizations for and stress test your production apps, helping your critical applications reach maximum performance for minimum cost. But we've only just scratched the surface. Come to our session this afternoon to learn more. Code, deploy, and scale Java your way at 3:30 p.m. Java devs deserve the best, and we're going to giving you our best to help you get it. Back to you, Julia.
Well, that was a fantastic demo. As you can see, we have made a bunch of productivity improvements to really make Java developers' experiences so much better. We want to continue to improve Java developer experiences with GitHub, with Azure, with Visual Studio Code. Now, we're not doing this alone. We are actively working with the various Java community organizations, such as Java Community Process, the Eclipse Foundation, the Apache Foundation, to make Java even better. Recently, Reza Rahman from my team just got elected on the steering committee for Jakarta EE. You can meet Reza at the Microsoft booth or attend one of his sessions. We have a dedicated group working on the Microsoft build of OpenJDK and optimizing it for Java workloads on Azure and the internal Microsoft businesses. We're also upstreaming patches to OpenJDK. We're super grateful for the trust and partnership of the various Java community organizations that we're working with. Our team has a booth on the expo floor. Please swing by, and we'd love to chat with you and to learn how we can make your experiences even better. Our engineers have a bunch of other exciting demos to show you, and you can learn more about our Java efforts on developer.microsoft.com/Java. Thank you so much, and happy coding. Thank you, Ted.
Thank you so much, Julia and Mark. Thank you for Microsoft for helping continue to push the Java ecosystem forward. Wow. Can you believe, as Shar put it yesterday, we're back. It's been 5 years since the last JavaOne. And yes, I was actually wearing the same boots at that keynote. So a lot's happened in the world in the last 5 years. Let's take a little sneak peek at some of the things that have come to the Java platform. We have seen new features every 6 months. That's been awesome. We've seen 10 new versions of Java, JDK 10 through 19. From Project Amber, we've seen record classes, switch expressions, text blocks. That's great. Hope you're using those things today. Continuing on with Project Panama, we've seen a preview feature of the foreign function and memory API and the vector API, an incubator of that. We've seen ZGC. We're going to hear more about ZGC today. Continuing on, helpful NPEs. We know you love the helpful NPEs. It was the winner of the feature face-off in 2020 that we did on social. And of course, virtual threads. Talk of the town, preview feature in JDK 19. We're going to hear more about that today, and we're actually going to see a demo. But I can't possibly fit everything onto the slide. How is it possible that we get this much innovation into the Java platform without creating complete disruption? The answer? Predictable, rock-solid releases. As you know, every 6 months, like clockwork, in March and September, we release a new version of Java. Did you know that even today, you can go and download the early access build of JDK 20? We're still 5 months away from the release of the GA of 20. You can be, oh, and furthermore, actually, we have scriptable URLs that allow you to enter those into your build and automation systems to ensure that your applications are always running on the latest versions of Java, including the latest patch sets. The release cadence is like the heartbeat that has made Java so successful for the past 5 years. And if it's the heartbeat, then something has to be the brains. That's OpenJDK. OpenJDK is where the magic happens. It's where Java is built, open and transparently, so that you know that your business can rely on the world's leading platform built completely in the open. Let's take a snapshot of some of the projects inside of OpenJDK. Each of these projects takes a look at the world and says, where are we going, tries to assess where the world is going, and tries to look at the Java platform and evolve it in a way that helps developers stay productive, solve problems not only from today, but also the problems that they're going to experience into the future. More importantly, or just as importantly, it's that we want to do that in a way where the platform evolves and it feels like Java, not something that's just bolted onto the side. The goal is when we release a feature, we want everyone to say, what took you so long? This is exactly what I was waiting for. Why didn't you just get it done a few years ago? Well, there's a reason that it felt like Java and it felt natural. Today, we're going to take a look at a few of these projects, Amber, Loom, and ZGC, as well as one of the important characteristics, the values that we thread across all of the work that we do inside of the platform, and that's platform security. So without further ado, I'd like to invite Gavin Bierman to the stage to talk about Project Amber. Gavin?
Thank you. So in Project Amber, we've been very busy previewing, refining, and releasing many new and exciting features. But these features aren't isolated. They've been carefully designed so that they work beautifully together. Indeed, when combined, they offer something that's more than the sum of its parts. Ultimately, they lead to a new style of Java programming that we call data-oriented programming, and I have a session about that later today. I'd like to show you today an example of combining two features. They are record classes and pattern matching. We've all written classes like this. very simple class. It's a simple carrier of data. But depressingly, writing such classes, here the class point is just a pair of integers, is quite a pain. There's a lot of boilerplate code to write. Boilerplate code is bad. It's a special class. It's a carrier class. The data that it carries is immutable. Record classes give us a compact way to declare classes that satisfy these two properties. Here's the equivalent record class declaration. It's a lot better. But it's not about syntax reaction. Forgive the pun, but that is not the point. The point is to tell the compiler that this class is a special one. It is a transparent class in that it has exactly two components, no more, no less. The compiler automatically provides you two accessor methods to get at their values. And moreover, those components are immutable. Once you construct the point, they don't change. This is strictly enforced by the compiler. Now hold this thought because it's important and we'll come back to it later. The second feature that we've released in Project Amber is pattern matching. A pattern embodies a test, and pattern matching is the process of testing or matching a value against that pattern. In Java 19, we are previewing a new sort of pattern called a record pattern. The idea behind a record pattern is that it embodies two operations. The first, a test whether you're of a record type, and the second, if you are, it destructures or disaggregates the record value. Look at this example here on the slide. I've highlighted the pattern in pale blue. Pattern matching against this pattern consists of a test whether you're of the record type pair, and secondly, if you are, it assigns the variable a to the value of calling the accessor method corresponding to the a component, and similarly for the variable b. We sometimes call this a structural pattern because it's really testing the shape or the structure of the data. Now this is only possible because of those two properties I told you about record classes. The compiler knows that every record value of type point has exactly two components. It knows the name of the accessor method, and moreover, it knows that the value hasn't changed since construction. So, what good is this? Record patterns, we think, are going to turbocharge your programming with record classes. Here's an example. It's a little contrived, but I hope it will speak to you of the possibilities. We're going to model a rectangle using a record. It consists of two abstract point components. An abstract point can either be a grayscale point or a colored one. Both of these types consist of a point, which itself is a record, and either a grayscale value or a color value. Now we'd like to write some code. We'd like to write a method that takes a rectangle, looks to see if the upper left point is a grayscale one, and if it is, I'd like to print out the x-coordinate and the value of the grayscale. And here's the code written using record patterns. It turns out to be quite easy and quite Java-like in its feel. We use 3 record patterns. Let's walk through the code. The first pattern, if R is not a rectangle, then we return. We've got nothing left to do. If it is a rectangle, then the variable UL will be initialized with the upper left abstract point. The second pattern tests to see if UL is a grayscale point. If it isn't, we can return. If it is, then P will be initialized with that point value. And then we can use the third record pattern to destructure the point and print out the components that we want. This is very nice code. It reads almost like a specification of what we were after. And of course, we can compare it with what we'd have to write without using any records at all. It's pretty disgusting, so I'm not going to dwell on it too much, but there's some nasty stuff in there. There's some casts. There's some very subtle null checks that are very easy to forget. Patterns, in particular, record patterns, are the way to go. But we can do even better. Between the parentheses in a record pattern, it's not actually a declaration of a variable. It's in fact a type pattern. And indeed, it can be any pattern that satisfies the type system. In other words, we can nest patterns. We can nest that point record pattern into the first component of the grayscale record pattern. And we can nest that inside the rectangle record pattern, which leaves us with a single pattern, like so. The pattern embodies all the navigation through the data structure, dealing correctly with nulls and so on. The compiler does the work for you. We just declare what we want, and the compiler writes the code. As I said, this example is a little simplified. More likely is that what you want to do is a number of things depending on the shape. No problem. In Java 19, we've also extended, as a preview feature, switch to allow you to use patterns as the labels. So now you can write code such as this that does one thing for one shape of another and something else for another shape. Record patterns can turbocharge your programming with records. Please take a look at the Amber project page to see how we're evolving Java to make you more productive. Thank you.
Thank you, Gavin. And thank you to the language team and the OpenJDK community for continuing to push the Java language forward. Next up, we're going to go down the stack a little bit. We're going to talk about garbage collection and ZGC. And to do that, I'd like to invite Mikael Vidstedt to the stage. Mikael?
When I started working with Java more than 2 decades ago, the world looked very different. At the time, computers came with one core, we call them CPUs, and maybe 100 megabytes of memory or so. Today, pretty much every device is multi-core, and memory is not seldom counted in terabytes. So hardware is evolving, and we are evolving the Java platform to meet the new expectations. And we do that by continuously investing in innovation. Now, that's true for all the different parts of the Java runtime, but today I want to focus on garbage collection. A garbage collector is the kind of component where if it does its job well, nobody will notice it. It just works. But that doesn't happen by accident. We spend a lot of time and effort in every release improving on things, and over time, that adds up to significant improvements. About a decade ago or so, we noticed a trend, and that was the ever-increasing demand for low latency, being able to run your Java applications with high performance and predictability. So we started Project CDC as a way to remove all the sources of latency from the Java runtime, providing you with a garbage collector that can run with extremely short pauses, even for very large heaps. Fast forward to today, and a lot of hard work later, CDC has been production ready since JDK 15, so which is approximately 2 years ago. And I'm happy to say that not only did we meet the goals we set up, we blew right past and exceeded them. Oh, sorry, can we go back one slide? Thank you. CDC today runs with sub-millisecond pause times, even for terabyte-sized heaps. And what's more, it does that with no or very minimal tuning. So let's have a look at what that looks like in terms of performance. This is showing an industry standard benchmark, and we're comparing G1 on the left. G1 is the default garbage collector in the JDK with CDC. This benchmark provides 2 different types of results. It's if we start with the lighter colored bars, that's the throughput score. And as you can see here, G1 is actually performing slightly better than CDC. But the impressive part here is the second set of bars, the darker blue ones. You can see that CDC performs significantly better on the latency score for this benchmark. And the way that CDC accomplishes this is by doing more of its work concurrently while the application is running, leveraging all those new cores we have in the systems. Now, garbage collection in the end is all about trading off different types of performance. And what CDC does is to sacrifice some minimal throughput in order to get the better latency. Let's have a look at what the pause times look like for this same benchmark. For each garbage collector here, you're seeing a few different data points. So it's the average pause time, a few percentiles, and then the max pause time as well. You can see that G1 is actually performing really well, with average pause times coming in around 150 milliseconds or so. But what about CDC? Well, it turns out that the bars are actually there. They're just so small that you can barely see them. So I'm going to help you. I'm going to bring out my enormous magnifying glass, and I'm going to zoom in 1,000 times. The y-axis is now showing microseconds, and there they are. There are actually pauses in CDC, as you can see. The thing is, though, that they're all well below 1 millisecond. And as a matter of fact, no real work actually happens in these pauses. It's just a way for CDC to make an internal state change, if you so will. But that's benchmarks. What about real applications? This chart came from an internal cloud team at Oracle. They took CDC for a spin, and without performing any tuning whatsoever, they just dropped it in. And I think you can all guess when ZDC was deployed here, right? When the switchover happened. This is the kind of validation that, of course, makes us very happy, but also makes me think that a lot of what we've done here will apply to your applications as well. So all of what I talked about so far is in JDK 19, but there's one feature that CDC still doesn't have, and that's support for generations. Now, it's true that virtually every Java application out there has a very specific pattern. That's the fact that almost all the allocated objects, they don't survive for very long. They don't stick around. We refer to this as the weak generational hypothesis. And by optimizing for this pattern, we can get significantly better performance and also lower footprint. So the numbers I'm about to show you are preliminary and straight out from our lab. But this is running Apache Cassandra. This is a NoSQL database. And what we're comparing here is at the top, the current CDC in JDK 19 with the new upcoming generational CDC. This is running with a fixed workload, and we're looking at how low we can set the heap size to still reach that, satisfy that SLA, sort of. You can see here that generational CDC comes in at only a quarter of the memory used. So that's a lot of memory saved, and in the end, money saved as well. But the interesting part here for this benchmark is that we're actually at the same time getting better throughput. So this is looking at how much we can maximize the throughput using that memory. So at the same time, we're getting 4 times better throughput at only a quarter of the memory used. Now, that's pretty spectacular if you ask me. If you want to know more about what we're doing on CDC, I strongly encourage you to attend Eric Osterland's session tomorrow afternoon, where he'll talk more about this. Now, I've talked about CDC, but what about the other garbage collectors, you might ask? Well, good news. A lot of the stuff that we did in the context of CDC actually applies to the other collectors as well. So let's have a look at G1, which again is the default collector in the JDK starting in JDK 9. It represents sort of a middle-of-the-road balance between throughput and pause times. And what we're seeing here is the same industry standard benchmark we saw earlier. You can see that there are improvements in every release, and throughput has gone up roughly 20% or so. But again, the impressive part here is on the latency side. The latency score has gone up by more than a factor 2. So that's a lot of good work that we've done over the years to improve on this. Now, performance does come in many different flavors, so I want to show you one last slide. A garbage collector is ultimately responsible for managing data on the Java heap. But in order to do so, it needs to do some bookkeeping, and that shows up as native memory footprint. We've done a lot of work to minimize the bookkeeping overhead, and this is what you can see here on this slide. It is showcasing an internal stress test that we use for garbage collection, and we're running with 20 gigabytes of Java heap. Back in JDK 8, the overhead was almost 6 gigabytes, which is quite significant compared to the Java heap size. But with every release, we improve that, and with JDK 19, we're now down to a single gigabyte or so. Oh, actually, yes. All of the kind of improvements that I've shown you here today are the kind you get by simply deploying on newer Java versions. Usually, you don't have to change a single line of Java code. So I encourage you to take the newest JDK 19 for a spin, and if your application is latency sensitive at all, do try CDC. We have early access binaries out. Thank you.
Thank you, Michael. The language gets a lot of love, but does the JVM get enough love? Let's hear it again for the folks that work on the JVM. Woo! All right, getting excited about low-level stuff. OK, so none of that would be possible without the JVM, but none of this would matter if your applications weren't secure. To talk about platform security and show us a demo, I'd like to invite Sean Mullan to the stage. Sean?
Thank you, Chad. So today, I'm going to be showing a demo of Java Flight Recorder with crypto events enabled. But before I do that, let's review some of the key features of Java security technology. So Java security consists of a comprehensive set of APIs and implementations for building secure applications. We support APIs and implementations, everything from cryptography to public key infrastructure, authentication and authorization, and network security protocols such as TLS and Kerberos. The JDK includes support for strong and modern cryptographic algorithms and protocols. Just since JDK 9, we've added support for SHA-3, TLS 1.3, RSA PSS signatures, CHA-CHA-20 ciphers, X25519 and X448 key agreement algorithms, and the Edwards curve signature algorithm. This progression shows that we are serious and committed to providing you with a solid cryptographic foundation for your applications. Providing secure defaults is also really important. When you run a Java application, many weak algorithms are already restricted by default, providing protection in higher level protocols such as TLS and Kerberos, and in artifacts transmitted over the network, such as certificates and signed jars. And we also don't just enhance our feature releases. We recognize the importance of providing a secure platform to run your Java applications on, whether it be Java 8, 11, 17, or the latest release. That's one of the primary reasons we created the crypto roadmap, to give you advance notice of security changes to update releases. And finally, we're also continually improving our tools to help you find and diagnose potential weaknesses. I want to show you one of those tools today. Waiting. Oh, good. OK, so what we have here is a simple application. It takes one or more command line arguments, each of which are HTTPS URLs. It then uses the HTTP client API to make a request to each of those URLs and sends a GET request. For this demo, we're not interested in the body, so it's simply discarded. However, we do want to make sure that the connection succeeds, so we print out the status at the end. So underneath the hood, this application is going to initiate a TLS handshake, and if successful, a TLS connection is going to be established. We're going to use Java Flight Recorder, enable crypto events, and then use Java Mission Control to analyze the security properties of the application. I like to call this taking the cryptographic temperature of an application. Now, when you install the JDK, the crypto events are not enabled by default. So what I've done is created a separate configuration file and enabled those 4 events by default. I'll go through each of these events in a little bit later when we run the application. So let's go ahead and run this application. I've already set up a command line with crypto events enabled, and we're going to connect to 2 hosts. The first is openjdk.org, and the other is oracle.com. OK, the demo gods are good. The JFR started, and we got good status from both of those URLs. So now let's go over to Java Mission Control. If I can see that. Okay. Let's just do that. Okay. This is JDK Mission Control. We're going to load the recording that was just created. And I'm going to make this a little bigger in a second. Okay, that should be a little better. So if we scroll down and we click on the event browser, and then we scroll down to the security folder, there are 4 events that we want to look at. The first is security property modification. There are no events generated. Now, this is good news. This means that the application has not modified any of the security properties of the JDK, and so it's running with the default security. We can see that there are 2 TLS handshake events. And if we scroll to the right, we can see some properties of that connection. Both of the connections are using TLS 1.3. That's the latest and most secure version of TLS, so that's really good to see. Both of them are using a very strong cipher suite as well, AES 256-bit with GCM and SHA-384. So this connection is using really strong security. That's good to see. The next event we can look at is X509 certificate. So every time a certificate is loaded and parsed by the runtime, an event is generated. We see 92 events, so you might wonder, why so many events? Well, that's because most of these are for the root certificates that are included in the JDK CA certs key store. In order to authenticate the server, the JDK has to find a root certificate that both the server and the JDK trusts. So we can see a lot of different fields. We can see the signature algorithm, the issuer, key length, key types. So there's a lot of good information here. The last event I want to show you is X509 validation. And these are actually pointers to the server certificate. So you can drill down and look at the actual server certificate if you want to. One other cool thing I want to show is if you right-click on one of the events, say X509 certificate, it creates a new page. And then we can go over and we can click on that page. And here you can perform queries on different fields of the event. So for example, we could query on the key length, or we could query on whether the certificate is going to expire at the end of the year. So this is a good way you can drill down and see if there might be potential security issues in your environment. I think that's all I have time for today. One other thing I want to mention, these events went into JDK 12, but they were also backported to Oracle's JDK 8 and 11. They may be in other JDK vendors' releases. And in JDK 20, we're adding more events. So we're actually building on this, and we really want to make a comprehensive way to monitor your security applications. And also, if one other shout out, the next release of Oracle Java Management Service will contain support for Java Flight Recorder and crypto events, and it will automatically produce reports showing potential issues in your environment. And I think that's all I had today. Hope you enjoyed the demo. Thank you.
Sean, thank you. Really appreciate all the work your team does to keep the platform secure. Last but not least, preview feature in JDK 19, virtual threads, an incubator of structured concurrency. We're going to hear about Project Loom, and we're going to see a demo. So he was gracious enough to take a break from his Reddit commenting. I'd like to invite Ron Pressler and Tomas Langer to the stage.
Hi, everyone. After almost 5 years in development, Project Loom has submitted its first 2 major JEPs in JDK 19, virtual threads and structured concurrency. Virtual threads are threads that you can have lots of. And by lots, I mean tens or hundreds of thousands, or even millions. And it is that ability that makes it easier than ever before to write high-throughput servers that make optimal use of the available hardware. Structured concurrency helps to combine or weave threads together correctly. Virtual threads use the same API as the threads you already know, so there aren't any new concepts to learn, but they're used in a very different way, so there are old habits to unlearn. For example, blocking is now cheap and even encouraged. You never, ever pool virtual threads. You create a new thread for every task in your application. Your tasks become your threads. The result is that you can use straightforward code with the APIs you already know and get the same throughput as you would with asynchronous code. But the shape of the code is only half the story. No less important is that JFR and existing debuggers support virtual threads. So the resulting program is not only easy to read without compromising on server throughput, but also easy to debug and maintain and observe at runtime. Now, Tomas, what do you want to show us today?
Okay, I will show demo comparing a service that is written for virtual threads with a service written for reactive environment and prove some of the points that Ron has mentioned.
Okay.
So on the left side of the screen, we have a service server-side that is written for virtual threads, and on the right side, we have a service written for reactive. As you can see, in a blocking world with virtual threads, you can use a for loop, execute your services, and then collect the results. If you go the same thing if you try to do the same thing in reactive, you need to have support for that in our reactive stream operators. So here in this case, we are using multi.range, which needs to be implemented in that reactive stream. And of course, you need to use all the operators that happen in the future. So you flat map on your counts, then you call your remote services and map it to obtain a result. And of course, you need to also handle things like error because it is happening in the future. So if you get an exception, try-catch block doesn't help you. It becomes even more apparent when you try to do something in parallel. So I will scroll to the part where we have the parallel execution. And again, on the left side, I create a new virtual thread per task executor to use virtual threads. And for each count that I have, I want to submit a task to be executed in parallel. So the first loop submits these tasks to the executor service, and the second loop just takes those features and executes a get, a normal blocking operation waiting for that thread to finish. If you try to do the same thing in parallel in a reactive environment, you do get into a bit of trouble because running stuff in parallel when you have reactive stream is way more complicated. And it doesn't look that bad on the screen, but those 4 lines in the flat map took us probably half an hour to implement, and I needed help from our resident reactive stream expert. So really tough to write, but also much harder to troubleshoot. So let's have a look what happens if you debug such a code. I will first execute the code against our virtual threads. So the first step is, let's make sure we are running in a virtual thread. You can see at the bottom, this is a virtual environment. We create our executor service. Default is 3 executions, and we just submit 3 times into an executor service. Now, if I go to this line, we can see that there was a small wait when the parallel execution happened. And of course, all the other features are finished because it was in parallel. So we could see that for each step in the debugger, there was a line of code that you could understand. It executed absolutely clearly. You blocked for the result. You didn't have to take care of anything. Now, if I do the same thing in reactive, again, we can see that we are running on a non-virtual thread. This is a platform thread because we are on a reactive web server. And now if I step over, hey, we are done. Like, something happened, obviously, but it's happening in parallel. It's happening somewhere else on an executor that you don't see. Even if I stepped inside of my flat map, I would still not see that wait of a couple of seconds. So in the end, both of these services work, but with Project Loom and virtual threads, we can actually code something that is really easy to read and really easy to troubleshoot. So now let's have a look at impact on performance that we have seen in our environment. On the left side, there is HTTP1 using JSON. On the right side, HTTP2. One of the main things on the right side, when we use HTTP2, each request coming to the server is a separate virtual thread. As you can see, this was running on 350,000 requests per second, meaning easily created 350,000 virtual threads and completed. So by switching from our reactive implementation, where the code is quite complex, to a very simple implementation on virtual threads, we have achieved up to 10 times more performance with Alidon.
Thank you very much, Tomas. I'm glad virtual threads helped you. So those of you who are interested in learning more about virtual threads, immediately after this keynote, I'll be giving a talk about them in room 221. And with that, thank you very much.
Thank you.
Ron, and to the team working on Loom, thank you very much for the hard work. And Tomas and the Helidon team, thank you very much. So we hope you enjoyed the Inside Java keynote, but before we break, we have one more guest to have on stage. He wasn't able to make it, but we were able to beam him in at least through video. So Dennis, the stage is yours.
Hi everyone, greetings from Ukraine. My name is Dennis Makogon. I'm a Java developer advocate at Oracle. I wish I were there with you at JavaOne, but unfortunately the situation here in Ukraine is what it is. Anyway, our team goal was to develop a telemetry ingestion engine for the Oracle Red Bull Racing Formula One simulator that collects all metrics and statistics. You can find these simulators on the show floor. In a nutshell, we developed a server using Java 19. We first used Project Panama foreign functions and memory API for packet deserialization based on C-struct classes generated by JExtract. Given a sheer volume of data we received, we figured out that our initial implementation was dropping packets. Therefore, we decided to add support for virtual threads in order to speed up UDP packet dispatching. While the ZGC with its sub-millisecond passes helped us to be sure that during the GC passes, we're not going to skip a bit. Soon you'll be able to read about this experiment at inside.java. Of course, you won't be able to notice any of that while trying to beat our pro-level driver track time, but you can rest assured modern Java has your back. Oh, did we mention Max Verstappen, that current reigning Formula One champion, was there at the conference setting the simulated track time? If not, I dare you, go ahead and beat him.
Thank you very much, Dennis. We wish you were here, Dennis, but thanks for all the hard work. Do check out the Formula One simulator that is on the showroom floor. He put in a lot of hard work into that data ingestion engine using all of the great features and many of the things that you heard about today. Okay, so finally, a couple things coming up. We have the Jeopardy game show, so head to the JavaOne Lounge at 3:40 p.m. where you can show off your Java knowledge against other contestants. So prove that you might be the best in Java knowledge. Next up, we have, of course, a reception, just like we had yesterday. Thanks to our sponsor, Mosaic ML, for sponsoring that session. That'll be in the Developer Hub at 4:30. And finally, don't drink too much, because we have the Unconference at 5 o'clock in Summit 217. This is your chance to be able to participate as a speaker in the conference if you're not already a speaker. Suggest topics. It's a chance for everybody to organize around topics that are selected on the spot. So that will be an Unconference coming up. And of course, thank you very much to our sponsors. Thanks again to Microsoft, Julia and Mark, for being here and all the great work that they've done, and Sonar and the rest of our sponsors here. And finally, don't miss the Steve Miller Band, which I think today is Wednesday, so that will be tonight. Live in concert here at the Cloud World Party. So thank you very much for coming to JavaOne 2022, and we can't wait to see you again.